Hi guys, and welcome to this video today for the Further Maths scheme on the cosine rule. That's Further Maths Units 3 and 4. But the cosine rule is used in Year 10, Year 11, Year 12 and probably every maths syllabus around the world. So hopefully it's useful to you. Now the cosine rule is going to build on my previous video that I've just recorded on the sine rule. And I tend to think of the cosine rule as being that much little bit easier. Uses the same idea as the sine rule. It talks about labeling the triangle in exactly the same way for non-right angle triangle. But yeah, the problem with the cosine rule is there are two formulas that you need to remember. Oh shucks, that's annoying. Yes, I know, I'm sorry, but hopefully by the end of this video you will have understood this and be maths gurus too. Yep, I'm Maths Guru, otherwise known as Darren, or probably more really known as Darren. And it is my pleasure to record these videos for me. If you could, and I haven't already done so, can you subscribe by clicking the doohickey in the corner or the subscribe button and just let me know you're watching. It's greatly appreciated and actually makes doing these videos a little bit worthwhile. Above me is a link to MaffsGuru.com, which is the website where you can actually search for these videos. They're all organized by textbook, by chapter, and have downloadable notes. What more could you ask for in life? Well, probably a lot at this moment in time, but let's get started. So in the previous video, as I say, we looked at the sine rule, which had that really revolting formula there, which interestingly, we only ever used two parts of. Right? We explained it had, an idea about ratios, we looked at fractions, and then we found out that actually our triangle can be labeled as A, B, and C, not just side lengths, but angles as well. And so long as we were sure that our triangle, if we labeled that as A, B, and C, so long as we made sure that our angles that were opposite it were labeled in the same way, then actually the rest of it was really down to the calculator and the ambiguous case with those triangles that can actually have two solutions. So that's recapping that. What has that got to do with anything we're doing today? Well, we said that actually in previous triangles, so long as we had two sets of sides with its own opposite angles, we could use the sine rule. But let's look at the triangle we have here now shown behind me. Well, does that hold true? Well, we have a side and an opposite angle, but we have a side with no opposite angle and a side with no opposite angle. So actually in this situation and in an exam question, you'd be looking at going, well, I can't use a sine rule here. There must be another rule. And there is. It's called the cosine rule. And so welcome, ladies and gentlemen, to the cosine rule, which says that if you have two sides and one included angle. Now, what does included mean? Well, every now and again, when you guys subscribe, I feel pretty included. It's like sending a little bit of love out. Not in a dodgy way, of course, but it just makes me feel included, a little bit loved between us. Anyway, moving on, strange analogy. But that's exactly what is happening here. Here is a side, and stuck between the two of them is an angle. And that's what it means by included. Rightio, ladies and gentlemen. Now, we use the cosine rule for when we have two sides and one included angle. That's what I've just talked about. But also, we can actually move the cosine formula around, and we can find missing angles if we have three sides. Okay, so this lesson is going to look at two sections of using the cosine rule. One, to find a missing side. One, to find a missing angle. Just to sort of head things over the past a bit, the formula I've just highlighted behind me basically is the formula for how to find a missing side length. And it's a squared equals b squared plus c squared. That sounds very familiar. Minus 2bc cos a. And here, ladies and gentlemen, we have that, the cosine of a. So that second formula helps me find a missing angle. As I say here, we are just going to make sure that we realize that we have the letters A, B, and C, in which case this here is angle B, this here is angle A, and that there is angle C, that quaint little seaside town on the Great Ocean Road. Lol, never gets old. Yes, it does. And as I said previously, knowing the formulas, awesome. Best to show how it is in an example. And so the examples, I'm very lucky, have been provided with permission from the Cambridge Further Maths textbook series, Cambridge You Rock, and I have to say it is a really, really good textbook series. So for triangle ABC, find the length of AB in centimeters. Okie dokie, we can do that. There is my length of AB. Now in an exam situation, I'd be looking at this going, all right, okay, it's not a sine rule question, it's a cosine rule question. It wants me to find a missing length, so I'm going to go a squared is equal to b squared plus c squared minus 2bc times the cosine of A. Now, I actually remember this formula in the strangest way. I remember that A there and that A there are related. And then I notice I've got a B squared and a C squared and a B and a C there. And basically, because they're the same letter, that's how I remember the formula. I'm sure you'll come up with your own ways of doing it. So as I said in the sine rule question, there is my formula. Now what I tend to do is substitute. So I take the values and substitute them in for what I need. Oh, which is the value of B and which is the value of C? Well, interestingly, in this situation, they're sort of trying to trick you. The values of B and C are effectively the values of the sides either side of the angle. So I'm going to ignore what they've put there, and I'm actually going to say, okay, so A squared is equal to 5 squared plus 10 squared. I'm going to minus 2 times 5 times 10. Now it's just 5 times 10. Lots of people strangely do 5 squared times 10 squared. I don't know why, it's a bit weird, but it's not. It's 2 times 5 times 10 times by the cosine of the angle that they've given you, which is 67 degrees. And actually, you're pretty much done. Now I could do a lot of this by pencil and paper and go A squared is equal to 25 plus 100 minus, or 2 times 5 is 10 times 10 is 100 times the cosine of 67 degrees. And then I can say that A squared is 125 minus 100 cosine of 67 degrees. I'm just going to use my calculator to be perfectly honest with you. So there's the working out we had before. I'm just going to clear it down. And so leaving that altogether. Now again, I'm not going to put this in and use the solve function. It seems really stupid to do that, all right? I'm actually just going to put it in as it is. 5 squared. I'm going to add on 10 squared. I'm going to multiply 2 times, oh dear me, times 5 times 10 times by the cosine of, what did I say, 67. Close the bracket and hit enter, and there we go. That's not my final answer. And again, sadly, so many people make silly mistakes here by forgetting there's one more step to go. That's actually the value of A squared. So I've got 85.9268 ... to tell the examiner that in fact there are more decimal places. How do I get rid of a square? I square root what I had, 9268 ... which gives me the A value of, let's square root, not tan. Sorry guys, honestly, you must be as frustrated as I am watching me actually do this. It annoys me that my calculator display is so small. But anyway, and that gives my value of 9 point, did it give a value to 2 decimal places? Yep, 9.27 centimeters. And again, I would be looking at that saying, does that seem reasonable here? 5, 10, and then 9.27 seems eminently sensible. If I had a side length there of, 49, I'd probably panic. Particularly if I got 85, I'd be sitting there going, I don't think so. All right, so that's one example using the basics to find side lengths. Now we're going to use an example to find a missing angle. So in this situation, it says find the magnitude of angle ABC. And if you remember, that always means the middle letter. So I'm looking for angle B, which is this angle here. Okay, life is good. So I am going to use my formula now. I know that the cos of angle A is equal to B squared plus C squared minus A squared, all on 2BC. Now, as I said before, this was a rearrangement of my previous formula. And there's no real surprise that that value of A there and that value of A there are linked together. Now, I don't want cos of A, I want cos of B. So we're going to do cosine of B is equal to, so in that situation, that's going to be A squared plus C squared minus B squared, all on 2AC. Now, without getting too hung up on what the actual letters are, again, I always remember that I'm adding together the two sides that are included on the other side of the included angle. So I'm going to say here that the cosine of angle B then is equal to 6 squared plus 12 squared minus 15 squared divided by 2 times 6 times 12. Let's scroll that over just a bit so I can bring my calculator up and still leave that working out in. And so now again, I don't want to try and do that whole thing all at once. I'm just going to do the fractional bit. I'm going to break it down bit by bit, otherwise your calculator could crack it. And so I'm going to do, there we go, I'm going to do 6 squared. I'm just going to do these in my head because honestly that squared button is doing my head in. I'm going to add that on to 12 squared, which is 144. I'm going to minus 15 squared, which is 225, but I'm just going to put 15 squared in to make sure. 2 times 6 times 12 gives me a stunning value of minus 0.3125. So cosine of b is equal to minus 0.3125. How am I going to get b? I do the cos to the minus 1 of that answer, which is minus 0.3125. And so I'm going to go cos to the minus 1, please, of my answer, close my brackets, hit enter, and out comes the stunning value of 108 point. Did it give me a degree of accuracy? Can't remember. 2 decimal points or 2 decimal places. So 108.21, and in this situation, degrees, because we were trying to find an angle. Let's minimize this. Let's move this over just a bit. And ladies and gentlemen, believe it or not, those are the two main ways of using the cosine rule. Okay, I've done one example with side lengths, one example with angles. The rest of it is just the same. Now, funnily enough, I tried to find questions for the sine rule in the past 4 or 5 years of the further maths exam. And to be fair, it was a quick flick through, and I was trying to do this relatively quickly. Couldn't find a sine rule question. Happy to stand corrected. If you think there is one, please leave a comment below. Otherwise, lots of them seem to be cosine rule questions. And here is an example from VCAA 2016 paper 2. During a game of golf, Selena hits the ball twice from P to Q and then Q to R. So she's starting at P, hitting it to Q, going from Q and ending up at R. The path of the ball after each hit is shown in the diagram below. Now, when I saw this question myself, my brain screamed at me it was a cosine rule. Why? I happen to have two sides of a triangle and an angle. They're trying to trick me here because I've actually got two angles added together, or two angles that I can add together. After Selena's first hit, the ball traveled 80 meters on a bearing of 130 degrees, don't care, from point P to point Q. After Selena's second hit, the ball traveled 100 meters on a bearing of 54 degrees from point Q to point R. Another ball is hit and travels directly from P to R. Lot of words there just to go to a cosine rule question. Use the cosine rule to find the rule, the length of, I think it says find distance traveled by the ball. So it wants me to find that value there, x. Can you see a triangle? Yes, you can. Let's zoom in just a little bit. Have they given you everything you need? Yes. Is it a cosine rule question? I should cocoa. So putting these two together gives me 104 degrees. I have one side here and one side here, which is the opposite. And so I get a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So let's say x squared then, because we called it x, is equal to 80 squared plus 100 squared minus 2 times 80 times 100 times the cosine of 104 degrees. I think in many cases it takes longer to write the working out than it actually does to do the question. Bringing up the calculator, let's see what we come up with. 80 squared, I could do in my head, but I'm not going to, plus 100 squared, I could do it in my head, but I'm not going to, don't want to make a mistake, minus 2 times 80 times 100, and we're going to multiply that by, if you will, by the cosine of 104 degrees. Hit enter, and 20,270 is not the right answer because that's my value of x squared, 270.75033, and so x is going to be the square root of that. So we do the square root, if you will, of my answer and press execute, and that gives me 142.37. Yes, 2 decimal places? No, because the question, strangely enough, said round your answer to the nearest meter. So that is going to give me 142 meters. 2 marks for that, which is actually quite generous, really. Then we move on to the next VCAA question. Let's minimize this for just a moment, make it a bit smaller so that it fits on. The hostel buildings are around. Now this is building on from a previous multi-part question. The hostel buildings are arranged around a grassed area. Marvellous. The grassed area is shown in the diagram below. Fabulous. The grassed area is made up of a square overlapping a rectangle. We can see that. Overlapping a circle, sorry. I can't read. The square has side length of 65 meters. Now actually, believe it or not, that is going to try and help us here. The circle has a radius of 50 meters. An angle theta is shown on the diagram. Use the cosine rule to show that the angle theta correct to the nearest degree is equal to 81. Now when it says show that question, it wants you to show the working out. Now why on earth is the 65 useful to me? If I know that this length here is 65, then I know for that triangle that is also equal to 65. And going to basic circle rules, if I know that the length of that, which is a radius, is 50 meters, then that there is also 50 meters because it's a radius as well. Why is it a radius? Because any point that goes from the center to the edge, which is there and there, is a radius, and they're all the same length. So drawing a triangle just so that I can take it outside of that there's my angle of theta, there's 50, there's 50, and there's 65. I'm trying to find an angle, so let's scroll up just a bit. So let's say the cosine of A is equal to B squared plus C squared minus A squared, all on 2BC. So the cosine of angle A is going to give me, again, I don't care what side B and C are, it's the ones either side of the angle I'm looking for. So 50 squared plus 50 squared minus 65 squared divided by 2 times 50 times 50. Righty ho. Firing up my CAS calculator, let's do my little fraction button. 50 squared plus 50 squared minus 65 squared, and I'm going to divide that by 2 times 50 times 50. Hit enter, gives me an answer of 0.155. So there is my cosine of A, 0.155. How do I get my angle? I'm going to do the cosine to the minus 1 of my answer. Hit execute, and that gives me, therefore, that A is equal to 81 degrees to the nearest degrees, and fist bump. Last part, or last one, this was on 2019 paper 2 as well. The diagram below shows a cargo ship next to a port. The base of a crane is shown at point Q. Now again, to be honest with you, I didn't see the ship or the crane, don't really care. When I'm looking at this and going, hold on a minute, I can see part of a triangle, I can see a side length, and an included angle. I bet it's going to ask me the cosine rule. The base of the crane is blah, 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 blah. To be honest with you, that is all rubbish. Not interested, but you should read it. What is the distance RP in meters? There is my distance in RP. It completes my triangle. It's completing me. And so this here is 120 degrees. This is 20. That is 38. It wants me to find X. Round your answer to the nearest meter. And in this situation, did you notice in 2016 or whatever it was, you got 2 marks for this question. 2019, 1 mark. Whoa. So A squared is equal to B squared plus C squared minus 2BC cosine A. Formula, substitute, gives me, oh, I've taken the question off the screen. So it's 20 squared plus 38 squared minus 2 times 20 times 38 times the cosine of the angle of 120 degrees. So A squared is going to be given to me as 20 squared plus 38 squared minus 2 times 20 times 38 times by, what am I doing, the cosine of 120, close the bracket, hit enter, and we get 2,604. That's my correct answer, yes and no, because that's the squared. So I'm going to square root my answer, hit enter, and out comes a value of A of 51.029. Leaving it at that, yes, nope, because it wants it to the nearest meter, and in which case, in that situation, A is going to be equal to 51 meters, or the value of RP in this situation is going to be the value of 51 meters. Now, interestingly, probably should have labeled all these A's as X's for my working out, and probably for my final answer, I should put RP equals 51 meters, because that was actually the value they were looking for. Are they going to knock your marks off for that? Hopefully not. Probably better to be safe than sorry. And sadly, ladies and gentlemen, that is the end of the cosine rule. 19 minutes in and we are done. Hopefully it's been useful. We've used the cosine rule to find missing sides, a variation of the cosine rule, or at least a rearranged version to find missing angles. We have looked at how they use in exam questions, and I think I'm ready for a lie down. Actually, I'm not going to record another video. If you have enjoyed this video, leave a comment below and let me know that you are watching. Subscribe if you haven't already done so. Can you send a shout out, TikTok or whatever else? It's really appreciated. Otherwise, hopefully I'll see you in a later video. Take care, stay safe. I'll see you next time. Bye-bye.